Limited, and you can reach out to me on Twitter as well, and some of the blogs I used to post on my website, you can reach out to there as well. All right, let's move on. So here's some agenda for the first session. Like we'll talking about the OOPS concept in the Salesforce, how exactly OOPS works in Salesforce. We'll talk about the MVC architecture and the MVC architecture of Salesforce, how those are different, right? So I make this session crisp and simple so that you guys are able to understand very quickly, right? So if any question you have, you can post in chat. We'll answer at the end, right? So let's move on to the concept of OOPS, right? So OOPS stands for as object-oriented programming language, as we have already, maybe you guys have learned in your curriculum or somewhere else regarding the OOPS technologies, right? So we used it in C++ and Java as well. Similar like we utilize in Salesforce also. So in Salesforce, we utilize OOPS concept with the help of the programming language, that is Apex, right? So there are basically the 4 pillars of the OOPS language that is available, and which makes the actually the OOPS programming language as object-oriented programming. So what are the 4 pillars? Let's see. So the 4 pillars are basically the encapsulation, inheritance, polymorphism, and abstraction, right? And also the class and objects is similar, right? It's always there, right? So let's quickly go one by one these concepts. Like see the first, encapsulation. So encapsulation is like the, as we have gone through already earlier also, you have seen that we bind the data together into a single unit, and we called it as encapsulation. I put it basically a picture over there for ATM, where we have the login validations and the process are hidden inside, and we just have a output whatever we got it, that is money from out of the ATM, right? So this is called actually the encapsulation we talk about. Like, so here I will try to make you understand with a small example how exactly the encapsulation works. So everybody has maybe gone through the childhood game Mario. If not everybody, I have already gone through that. So I'll take an example of Mario to understand the concept of OOPS, right? So let's quickly take an example how actually it works, right? So this is the small program that I've taken. Like here, this is the Apex language that I'm utilizing, right? So this is the interface that is given in Salesforce on cloud, that is called as anonymous window, where we can run our classes and create the classes, right? So this is a small example of Mario. Like this is a simple class which we create earlier. We used to create in Java as well the same way. Like we have created class Mario, and since I said the binding of the capabilities and abilities of Mario in a single place, we call it as encapsulation. So what will be the capability of Mario here? He can walk and run, and kind of info we can give. So these are some member variable member functions, or we can call it as functions which we have created, member method which we have created to define the functionality and capability of Mario over here, right? So like object programming, we have everything is minded inside a class. So this is a class in which we have member methods are minded inside it, and some of the things, whatever the functionality they are written inside the blocks, right? So let's quickly see how actually we run these class. So in similar in Java, we use basically system.println to print anything on a console, right? But here we utilize system.debug to print anything on a debug logs, right? So here, like in Java, we also create this way creation of objects. So first we'll have an instance of the class, right? And we have a member variables or reference variables, we call it as, which is going to instantiate an object inside it. So this is the object creation that we have done, and this object is held by this reference variable. So anything inside this object we are going to reference with this reference variable. So everybody knows that, maybe or not, but yes, until unless any class gets instantiated, we cannot access the members of the class, right? So that's why I have instantiated this particular class here with the reference variable m, and I'm accessing this particular member methods of this particular class with the help of the reference variable. So if we quickly run this, you'll have an output like whatever the functionality and abilities that Mario can perform. So yeah, see, right? So this is a small example of encapsulation, how actually encapsulation works, like the binding of data into a singular unit, that is called an encapsulation. Now, so let's say talking about some like in every game we have, there are some power boosters we have, and such as speeding and taking bullets and so on. In Mario also we have some power boosters will get, and the Mario will increase his size, right? So like there are some power boosters, right? So if you want to change the behavior of Mario in the game, what you need to do, you have to write so other code, other line of codes also inside that, right? And if you write some additional codes in existing class, there might be high chances that the functionality of the existing class will break due to some introduction of new codes, right? So with the feasibility of OOPS, what it suggests that do not need to modify the existing class. We just need to write our we just need to extend our existing class and create a new class, so that the existing functionality will have those functionality with the another class also, and he can have their own functionality as well. So that concept is utilized as inheritance in OOPS, right? So let's take about inheritance. So when one object acquires all the properties and behaviors of parent object, like I said, if we utilize the existing class and create another class, the functionality of the existing class will have the in the new class as well, and he can have it can have the existing functionality as well as the new functionality, right? So inheritance can be achieved. It can be used to achieve the runtime polymorphism also, right? So in Java, you have seen multiple type of inheritance like single level, multi-level, right, and hybrid, right? So, but here in Apex we have only single inheritance, and in Salesforce we say non-virtual and non-abstract type cannot be extracted. So I'll talk about virtual and abstract later on, right? So let's quickly see an example how actually inheritance works. So we have one class that was Mario, which can walk and run. Now we will create another class which has an existing functionality as well, and he can fly also, right? So let's take an example here. Let me comment this. So the very most important thing to understand regarding inheritance is there are some keywords that are needed for inheritance. First thing is the virtual. You might be have seen in Java also, not in Java, and C++ also, like virtual keyword. So virtual keyword states that the class or method can be inherited or overridden by the child class. If you are not writing any virtual keyword before any inherited class or parent class, that class cannot be inherited, right? So that is the main keyword that need to utilize, right? And extends in other keyword that we use to inherit the parent class, like this is also used in Java, right? We utilize extends to inherit. And like the third keyword is the override keyword, that if we are writing, let's say this override keyword is utilized in the achieving the functionality of runtime polymorphism. I will show you in few moments, right? So let's say if we are writing the same method of a parent class inside a child class, then that method should be utilized with the keyword override, right? That keyword should be there, then only that particular method can be override, right? So similarly, there is another keyword that is super. So what happens if you have like say override one particular method and inside a child class as well, and you want to call that particular method, then you want to call the method from the parent class, then you have to utilize this super keyword, right? So this will define the compiler that this particular function should be called from the parent class. So let's see an example here. So this is a small example which I have created. Like you have again same class, we have created the virtual method here, right? So this is the virtual method that this can be overridden, right? But right now I have created another class that is a child class, which is going to extends your parent class, that is Mario. Now you can see this particular class have two methods like ability and info, and I have the child class which is extending the parent class, which have two another methods like ability and my info. That's it, one, right? So if I run this particular method, now understand this concept here. I have created a first then object of parent class, that is a reference variable obj, which is holding an instance of Mario, that is a parent class. If I call this method, this reference variable with info, it is going to call your parent method, right? And let's say if in the second part, I'm same reference taking and creation of instance with the new class, let's say. All right, and here I have called all the methods, the parent one also and the child one also. So let's see the output. Sorry, what happened? Method does not exist or include signature void type. What happened? Something went wrong. Ability 1 info. Sorry, it's info. Info. Ability 1. Let me see another again. Line number 14. Sorry, as I said, virtual keyword needs to be there. Save. Let me run only one method first. Get back to this. What happened, man? Let's see. Come on. Let me take everything here. What happened, man? Something I'm missing. Come on, line number 14. Let me remove this also. Check. So as you can see herein, I have called the parent class method from the child instance also, and it has been called. And if I want to call the child class, let's say ability one, something I'm missing, I guess. I don't know what. So only the matter of what I want to make understand that from the child class you are able to access the parent class variables.
I think you can actually check the panelist chat.
Okay. Not from Mario. This particular same class I have utilized have a same function with a different member variable, member parameters, right? So based on the compile time, it will define which particular methods needs to be called, right? And based on that, you will have the output in this way, right? So a small example of function overloading that we have seen. Now let's see the function overriding. So function overriding is simply defined at the runtime basically. Like when basically on the compile time, it will check that which function needs to be called. So this is called function overloading basically. Function overriding, sorry. So let's take an example of function overriding. So, okay, I was calling actually the function overriding earlier. That is why. The same class I am taking. But in a different way. So what happens in function overriding? Let's say the parent class is this same, and then the child class, I am overriding the function which I have taken here, right? So ability function which I am overriding, you can see the function name is same, and I'm overriding the existing function in which the method is saying it can walk, right? And when I overload that particular function, I have written in that it can fly. But yes, I have utilized the keyword that is super, which will call or tell the compiler that he needs to call the function from the parent class, right? So super keyword will define that this particular method is getting called from the parent class. Like, so let's see an output how actually it works. Sorry. So now see the output, and let's understand once again. So this is one parent class and this is a child class, right? So on the child class, I have extended, and there are same function I have utilized here, that is ability, and this is the ability also, right? So I'm overriding that existing function. So as I said, to override the existing function, we have to utilize the keyword that is called override, right? So what it will do when the function calls, now if you see here, I have taken the reference variable of parent class, right? And instance of the child class, right? So when from the reference variable of parent class I'm calling info, it is going to call the child class, parent class method, right? So you can see I'm Mario, right? From the parent class, then I can walk from the parent class, then I've instantiated the child class, then object.info again call the method from the parent class, right? And object.ability, when it's called, before that I have called the ability there, right? So object.ability, first it will call the super keyword, that is ability, which is the parent class method, which have the content like I can walk, and the next I have written the child class, that is I can fly. That's why the next output is the child class. So in this way you can define the function overriding, in which at the runtime the compiler is going to define which function need to calls from the child class and which function needs to be called from the parent class. So this is a small example of the function overriding. So let's moving on to the next topic, abstraction. So abstraction is a way in which we can achieve the polymorphism and abstraction in Apex, right? So interface is the way in which we can achieve the polymorphism and abstraction in Apex, right? So interface are like I would say a contract which only add a declaration to the class but not the actual implementation, as we have seen in Java and also Java also, that interface will have some functions which are not defined, they are declared only, right? So if there are functions which are let's say two functions are there and one function is defined, that class is not called as interface, that class will called as abstract class, right? In a similar way, abstract and interface are two ways in which we can perform the abstraction. So I will take an example of interface here. So interface, let's say we have a game level number and environment. Like there are two methods which are declared there, they are not defined, and there are two basic classes, the child classes, which are going to implement this interface and provide some definition to the functions or which are declared in interface, right? So let's see. So this small interface, creation of interface is the similar, like public, then interface keyword is there, and we have the class name, then interface name, then there are two methods which I have declared that are declared only. So these are abstract methods basically, right? So all the methods are abstract, then class is called as interface basically. So I have created one class that is label ground, which is implementing the interface game label and has defined two methods which are available in interface, label number and environment, right? So in the first method label one and the second method environment, the label will be played in underground, right? So and the second class which is also implementing the game and game level and has some different parameter, some different definition, unlike the first class, right? So this also implements the interface. In this way we can utilizing the one particular class and with a multiple class, right? So this is called the interface basically. So let's see the output, how actually it goes. The similar way, if I want to call similar, I can simply call dot label number, and now Apex is case insensitive, it's not case sensitive, so it will work. So the declaration of the interface is the same way, you can see public interface game label. This is how we actually declare an interface, right? And we utilize the methods in child classes, right? So this is how actually we call the child class and we have output accordingly. So this is the way how we actually implement the abstraction in Salesforce. Any question on basically the OOPS concept? Let me see the chat. So
I think Shiv, you can actually take up the questions towards the end,
all
and
right.
I request everybody to post questions on Q&A tab rather than putting over the chat, because we would not be able to get those things. So yeah, for the questions, Shiv, we can take them later also, not a problem. Yeah.
All right, sure.
So guys, please
So
feel free to post questions. Once the session is over, Shiv can actually answer the questions over the chat itself.
all right, so let's move on to the MVC architecture, right? So as we have seen, also known as the MVC architecture is known as the model view controller, in which model is basically your database or data model that are going to be used, and view is basically the interface from the user is going to be interact, and the controller is the logic which is going to connect with the model and the controller or the view, right? So these basically MVC architecture we called here also. So in Salesforce, there are two approaches basically we utilize to develop any program or any application, right? So one is the declarative approach and another is a programmatic approach. So both have the different MVC architecture. So let's talk about the declarative approach, in which we do not need to have any code also. So although there also we have the MVC architecture, right? So how actually these are different. So in Salesforce we have some called page layouts and the record types, right? So these are the user interface with which the user are going to interact. So these are known as the view basically, right? Then there are the workflows, validation rules, and approval process. So these are the business logics and the validations that is used in Salesforce, that is known as the controller here in declarative approach. And the next one is the object, fields, and relationships, right? So object is basically unlike the table that you have seen in database also. So this is basically an object, and columns where there in database we have columns. So here these are known as fields, and relationships between the objects are there. So these are some data models basically in Salesforce in a declarative. So while we talk about another way, that is a programmatical approach. So the user interface is the Visual Force pages, Visual Force components, right? And the lightning components also are known as the user interface by which user are going to interact. Then the business logics is the Apex controller. Apex controller is nothing, the class which I have written. This is also known as the controller basically. So you can see the .apx defines for Apex controller, right? Or Apex class, you can say. So basically this is basically an Apex controller, and Apex trigger is also a term in Salesforce, which is you have also gone through the triggers maybe in your SQL and other technologies. Then this is also available here in Apex. So this is basically comes under the business logics, or we call it as controller, model view controller, in which the controller is the Apex controllers and Apex triggers, right? So data model in terms of programmatic, we have the metadata APIs that are object metadata, whatever the object metadata will have. Like when you in SQL you describe a particular object, so you have all the structure of the table is there, right? So that is the metadata available here for an object, right? So REST APIs and bulk APIs, these are all data model available in programmatic approach of MVC. So I will walk through you the Salesforce interface to define how actually these MVC architecture looks, right? So give me here. So model view controller pattern is the same as I said. The model is basically your Salesforce standard objects and custom objects, right? And the controller is basically a logic which are going to interact with the view, and view is your Visual Force page, right? So let me walk through quickly to the interface of Salesforce. So this is interface of Salesforce in which everything you have seeing here, this is a basically view, right? So if you click on any tab, this is also a view available given by the Salesforce. We have not created it. So anything that you are creating. So let's say the tab you are using here, this is a view, right? And when you click it and go here, so it is the view which you are accessing, but this is also an object attached to it, right? So when I click on a tab, this is a view, and inside that there is an object structure which is holding these data, right? So that database, we are interacting through the this tab, and we are getting the view of all the data available in that particular object, right? So there are logics written by default inside the Salesforce that is called controller basically. So that is here. So you can also build your own model view controller with the help of Visual Force Pages and Apex, right? So this is a small view you can see available here for all the, I would say, objects that are available, standard objects that are available in Salesforce. So these are all views, right? So that's it about the model view controller, nothing much. And these are the references which I have taken from the slide for the slides. That's it from my side. Now let's see the questions.